Okay, so Hart spoke about DAOs and how we need this enforcement mechanism behind this. So we're going to talk now about the optimistic oracle, which is our solution to bringing on this long tail data that Hart spoke about. So Hart had this same slide, but there is this misconception that oracles are a mechanism for bringing price data onto blockchains. And this is primarily where they're used today. You create a money market or some sort of lending protocol or whatever, and you need the price of BTC or price of ETH to do liquidations. But ultimately, oracles are much more than this. And like, if you actually look at the origins of this word, it is more than just about pricing. It is ultimately a truth machine, something that we use to bring real-world information that the blockchain could never know about onto the blockchain. So there are many types of truths that we might need on a blockchain. And like I said earlier, pricing is just one kind of this. We could do long-tail contracting, like Hart was discussing, but also a wide range of other kinds of financial contracts and financial derivatives. So today, DeFi is really just this one slither. What is the price of BTC? Can we do a liquidation? But in the long arc, this is going to be so much more, right? And our core thesis is that today, oracles are only really being used for, say, 10% of what they're eventually going to be used for. And if we're going to actually achieve a world in which DeFi and DAOs and all of this is actually competing with the traditional system, there's going to need to be substantial growth in the information that we can bring onto chain and actually arbitrate things that are happening in the real world using a blockchain as the settlement layer. So price feeds today are very much a push-based system. If you look at things like Chainlink, for example, you're pushing prices all the time to actually enable these protocols to work. And this is all about verifying data sort of correctness in advance and then pushing it on-chain. The important thing with these is that there tends to be almost never an arbitration mechanism if things go wrong. So if you push a wrong price, what happens? Well, your liquidations have gone through and now we're in a bad situation. This hasn't happened that badly to date and with existing Oracle solutions, but it is inherently brittle and things can and will go wrong. So that's the one element, and the other thing I think is that they're very restrictive in what we can actually do. So if you want to have like long tail complicated data, APIs are not necessarily going to be the right solution for this. So Web3 needs a long tail oracle, something that we can use to bring in more complicated data on chain. And ultimately, this needs to enable us to create verifiable claims of information. Ideally, also, this needs to be cheap, right? This idea of pushing prices all the time is not exactly an economical way to do things, especially when chains have limited capacity. If you're not bringing on a lot of data, then maybe that's okay. But this long tail is going to bring on a lot of information. And I guess the last key component is having some sort of arbitration or human judgment layer, where if things go wrong, especially if the information is complicated, we need a way to arbitrate that. So our solution to this is creating a mechanism called an optimistic oracle. And you can think of this in a similar way as you would think about like an optimistic rollup, where you have things happening in some separate system, and if things continue to work correctly, then we continue with the happy path, and only in the event of fraud or something going wrong do we arbitrate. For us, what this lets us do is bring on any kind of information on-chain, and we enforce the correctness after a dispute. So as with like an optimistic roll-up, you basically introduce a liveness period, and we'll look into the mechanism shortly, but use this liveness period to let people verify the correctness of information brought on-chain. And the really powerful thing about this is it doesn't limit the kind of data you can bring on-chain. Normal oracles are, like I mentioned earlier, very limited in what we can bring on, but with this, you can literally ask any arbitrary question. Like anything is possible to be brought on-chain with this. The other benefit is we can add in economic incentives into how complicated or how expensive it is to manipulate these oracles, whereas in more like push-based methodologies, this is a bit more difficult, and we can look into that in a bit. So what is isUMA? So we are an optimistic oracle. Well, one of the products that we offer is an optimistic oracle that can provide and verify arbitrary data on-chain. And we use this to secure lots of different smart contracts and different kinds of financial applications. And ultimately, this is a mechanism to tell truths about the world onto the blockchain. It is inherently a truth machine. So there's some things that have already been built on isUMA, including prediction markets, DeFi insurance protocols, optimistic governance, like what Hart was talking about, cross-chain messaging and bridging, KPI and success tokens and options, which are sort of very bespoke financial derivatives. And the point really is, like, any kind of financial product can be built using this framework, including like a much wider set of things that what you can do with traditional Oracle designs. So let's go into like the actual nitty-gritty of how an optimistic style Oracle would actually work. So there are 4 key components that we need to create one of these mechanisms. The first thing is we need a network of people that are going to be requesting prices, proposing prices, and then disputing prices. So a price requester will be a protocol that actually needs specific bespoke information. Maybe it's a prediction market, right? Like, what was the outcome of the election, or who won the Super Bowl, any kind of arbitrary question. Then proposers are a group of people that are going to be watching these requests come in and submitting answers to these questions. And they're doing this due to what I mentioned earlier around the economic incentives of the system. So we can add in rewards and bonds and a bunch of other economics to make sure that all these actors have aligned incentives to perform the correct things. Then the disputers, they sit off on the side, watch what's going on with the proposers and requesters, and sort of police the system. And the really important part about this is you only need a single honest disputer to be online to make sure that the entire system is secure. You can't get fraud through if there's just one person watching. And that's really important because there's no like honest majority assumption or anything like this. It's just one actor needs to be watching the system, detecting fraud, and they can pause or interrupt the process and go to arbitration, which we'll talk about as well. So then you need a dispute resolution mechanism, which is this arbitration process, and we have our own system for doing this at isUMA. Another thing that's very important is having a documented process for actually converging on the truth, right? The people that are proposing and disputing need to have a well-defined rule set on what the truth actually looks like and how we get there. If there's ambiguity in like what the actual definition of this price request is, then you're never going to really be able to come to a consistent like deterministic outcome for a request. And then economic bonds and guarantees to both incentivize and to secure the interactions between these different players in this like repeated game. So this diagram basically shows the flow of an optimistic Oracle request. So first thing that happens is someone asks a question, right? And in this example, we're looking at, was this relay fulfilled on a deposit? So one of the products that we've built or incubated at isUMA is a cross-chain bridge called a cross, and we use the optimistic Oracle to verify the correctness of deposits moving between chains. So a random piece of information, but not available on the destination chain. So we asked the question, was this relay fulfilled? Did this relay fulfill the deposit on the layer 2, right? Then a proposer can come along and see either yes it did or no it didn't, and they can propose an answer to the solution along with a bond. The disputer can then see this. Was this correct or was it wrong? If they think it was right, then they don't do anything, right? The optimistic path, the happy path is do nothing. You wait through the liveness, and at the end of the liveness, we then know that this thing that happened was taken as correct because it was not disputed. Therefore, by definition, it must be the only correct answer. And we then take that as the truth of the world. In the event there's a dispute, we can then enter into an escalation game, effectively, where we submit these disputes to the DVM. So the DVM is the data verification mechanism, and it's isUMA's arbitration mechanism. I'm not going to go into too much detail about how this works, but for all intents and purposes, it's a Schelling point oracle based off of Vitalik's Schelling point paper 4 or 5 years ago. The basic idea is that you take all the isUMA token holders and they vote on what the correct resolution should have been in the dispute using a commit-reveal scheme. So the voters will commit to an answer and then reveal, and by using the commit-reveal mechanism, basically you can't see what everyone else is voting on. And therefore, the only economically rational thing to do is to vote on the correct price. And these incentives come about because we now have a slashing mechanism as well as rewards for people that vote correctly. So if you vote wrong or against the Schelling point, then your share of the total isUMA supply will deflate over time. So yeah, economic incentives around converging on the correctness of the price, but we only really need to use that system in the event of a dispute. We've been running this system, this optimistic Oracle system on mainnet for about 1.5 to 2 years now, and we very seldom actually get to the dispute layer. We process a lot of requests mainly for prediction markets and for bridging protocols and things like this. And almost never does it get to the DVM layer because these economic incentives sort of up the layers as we go are robust enough that, you know, if you do the wrong thing, you will lose, right? When it gets to the DVM will converge on the correct answer and you'll lose your bonds. So one thing that's kind of cool about the optimistic oracle is that it's inherently able to be deployed onto a multi-chain world. So this sort of request, propose, arbitrate flow is inherently asynchronous. So what that means is this is actually a really great design to put onto many different chains, and then you basically leave the optimistic oracle on the layer 2 or the rollup or whatever, and only in the event of a dispute do we take the message back to layer 1 where we arbitrate it in the DVM. So we have the optimistic oracle, I think, on like 8 different chains now, and you know, you only need one DVM on layer 1 to arbitrate in the case of fraud being committed on these chains. And yeah, that's worked pretty well so far for that. So some kind of questions or that the oracle can answer, which is powering some interesting products. So Polymarket uses the optimistic oracle on Polygon as their main settlement layer. We have insurance protocols that ask, was this protocol hacked? Which is Sherlock. We have Across, which can answer questions like, was this cross-chain relay valid, right? We have success tokens, like the Fox token uses this for their like success tokens, which is the Shapeshift protocol. We have Bobo, which have created like also success tokens around if their TVL reaches certain metrics. And I think the really important point of this is to just realize like these are completely divergent questions, right? These are all very different kinds of data from very different sources in different environments. And there wouldn't really be another mechanism where you could bring this information on chain in a robust way with economic guarantees, without actually using a sort of commit reveal mechanism for arbitration and an optimistic oracle for actually bringing this data on chain. So we can really power all these different solutions. So what is the end goal for this? Hart spoke a lot about this idea of generalized contracting, but it's also really everything else in DeFi, right? Like, as you saw on the previous slide, we didn't talk anywhere there about money markets or synthetics or anything like this, because that's only like the tip of the iceberg. The long tail is really where DeFi is going to grow, and if we reach, you know, mass adoption, like ultimately there's going to be a wide range of additional products that we haven't even thought of. And it's very limiting to just be thinking in like that small slither of just this is the price of BTC. So the key takeaways, I think, are that oracles today are built for this fat head, this like left slice of the graph, and they can be wrong. There's no sort of arbitration or mechanism for recourse. But ultimately, Web3 is going to require truths and data that's more than just prices, right? There's this entire long tail that we're targeting. And optimistic oracles like the one that we've built, we think is pretty well suited to capture this long tail and to actually bring on this more complicated information on-chain. And ultimately, yeah, the need for this kind of information is much bigger than just price feed oracles, right? Like any kind of contracting that you would want to build that needs something slightly more complicated is going to need a more sophisticated oracle. And I think that optimistic oracles, like the one that we've built, is a critical mechanism to actually enable this sort of generalized contracting and to enable projects to build sort of bespoke forms of any kind of financial contract or derivative or organizational structure, ultimately. It can arbitrate any information that you need. So that is my talk. You can check out more about us at isUMAproject.org, and please hit me up on Twitter as well. No questions. Question?
Thanks. Yeah, you're saying that the sort of fat head of things is the, I guess, the like price oracles and things like that. And these questions are more generic, but they're still kind of global questions. Would this be possible to use for more local questions? So like going on a smaller scale might be like delivery of an asset and the temperature of that asset. That's like very, very local, and not everyone will have the answer for that. Like at what size do you think this sort of teeters off and it needs to be something else?
Yeah, so I think the important detail is that the proposers and disputers in the system need to be able to publicly verify the information. That's really where the limiting factor comes in. And if you just consider like the flow of a price request in the case of a dispute, if it gets to the DVM, the voters also need to be able to verify it. So I'd say like the line that we draw is anything that's publicly verifiable can be brought on chain using a system like this. If it's private information, I mean, maybe there would be a system where you could use some ZK or some other technology to sort of verify the correctness without revealing it. But I think that all of those kinds of systems are going to introduce some other trust assumptions. So for now, our target is publicly verifiable information. Cool. Thank you.